This video will demonstrate a Raspberry Pi being used as a hardware interface to remote control a K3 from either inside the house here or even any location in the world using the remote desktop, a remote IP camera, and a VNC viewer. On the right is the remote setup with tight VNC. We have meters. The top meter, the VU meter on the upper left there, is for the K3 output, audio output. So you hear that going on right now. And the bottom meter is the incoming to the Pi, which will reroute the audio to the rig for transmission. I'm hearing the rig, and you're hearing the rig from this application called Jack Trip. It's a very low latency and uncompressed audio, so you need a little bit of bandwidth for this to work properly. So if you have anything less than 2-3 megs, probably won't work that well. Need about 1 or 2 megs for your upload, then everything should go fine. But this is the best way to get low latency, which is favorable as far as, the smoothness of the operations. On the left side is the remote computer itself, and on the upper left is the IP camera looking at the scope waveform. So I'll throw out a CW, see if the frequency is in use. And you can see the RF from the rig, so that helps me keep an eye on things. Make sure the K3 is performing well and that the keying is working. On the bottom left is the application that takes a 555, turns it into a sine wave. The sine wave goes to the speaker so I can hear it, and you can hear it. It also goes to the Pi, the input of the Pi. And that would be Jack Trip over here on the Pi. So it's receiving the audio from my remote computer on the left, and it takes that and sends it to an audio derived CW keying switch, which keys the CW jack. The K3 is on Vox for both CW and single sideband. The G-Rig application can go CW or some of the other modes there, so I'll demonstrate that in a minute here. So I'll throw out a CQ and see what happens. The camera on the bottom on the left side here is just so you can see what I'm doing. And this is on the local side. This is my remote setup. So let's throw out a CQ here. See what happens. The G-Rig is useful for switching from Morse code to single sideband, and for adjusting the frequency. I haven't tried most of the other features, and the filter doesn't seem to do a good job, so I just leave the filter where it's at. So let me go up and down here a little bit. Just left click or right click, left click climbs the stairs, and the right click lowers depending on what number you click here. Then we can go down to 2 here. So we'll climb back up. There we go. So we're able to use both the straight key and the iambic paddles with these 555s you see here on that circuit board. There's an FET opto isolator that grounds the pin 4 of the 555, which sends an audio output, a tone output, into a microphone, USB microphone jack. And that USB microphone jack, in turn, gets regenerated through this regate. This trigger threshold on the left here, when the volume goes above that, it triggers a MIDI note, send MIDI. Then we're doing MIDI note 54, and that sends a precisely duplicated CW element that it received on the mic input, and then sends a MIDI note with those exact same timings to the next step, which is the signed CW, and that is the synthesizer that creates the CW wave. And we're using it for a side tone as well as sending it to the Pi and then to that audio-derived CW keying switch circuit. And that grounds the CW keying jack. Okay, now let's review the way to switch to sideband. So let's climb up a bit. And let's go and change the mode.
They can't make their mind up what we're going to get. I've seen anything from a couple.
Is this frequency in use? Okay, I just wanted to show you that. I didn't want to have a QSO there too, otherwise the video would be too long. But this audio, this USB mic, comes into a VST host using Linux and WAN. And we have a gate on it right here. And then it goes just to a automatic gain control. So as you see, when the green lines go below the threshold, then it turns off any of the microphone noise or any of the audio input of the microphone. Then it sends it, when it's above this threshold, it sends it to the next stage. And that's this one right here. So no matter, get about a 12 or more dB, it's kind of like a gain limiter as well. So I don't have to talk exactly and precisely the same volume for this to get -6 dB. And that's what's going into the simple screen recorder. However, going into the K1EL, we use another one, and that's at -25 dB, which is just below the threshold of the ALC and the K3. And so this is adjustable, of course, but with a very steady volume, you want the least amount of ALC possible and still get full power. So I'm pretty stable at -25, and that's just about what it takes to get enough power. So I don't see any point right now in going over this, but if you needed more, you just look at your watt meter and then dial this up until it's just enough to get full power. Then that way you don't have to activate the ALC that much and you get less distortion. Now on the Raspberry side, it's sending it to the system. This system is the USB sound card that's already in the K3, the K3S. I have the modified one that has a K3S. So this is the K3 output, and this is the K3 input. So my voice on CW is not loud enough coming over jack trip to go here. It's not loud enough to activate the CW key. And when I have it in lower sideband, then it is loud enough. But on CW, you can do AFCW mode, which I haven't enabled on the K3, but it has to be at a certain volume in order to activate the Vox threshold, as well as the CW keying switch. So if I shout or something, then it'll activate that CW keying switch. But my mic volume here is so low that there's not enough energy getting to that CW keying switch, which is key the rig. So I'm using the Raspberry Pi's own analog sound card output to go to a keying switch. I actually have two circuits. One to actually hit the CW jack, and this playback 2 is to activate the push to talk before and just after. So if we come back to FL Digi here on the left, I'm sending basically a stereo signal over jack trip. So let me show you what we're doing here. Using the QSK write control. So 8 milliseconds before the CW note goes on the left channel, and 2 milliseconds after, the push to talk receives this amount of timing. So it's an extra 10 milliseconds, 8 milliseconds before and 2 milliseconds after the actual CW wave goes to the other audio-derived CW keying switch. So on channel 1, which is right up here, this one right here. So output 0 is the left channel, and that's the pure 700 Hertz CW tone. You can shape it however you want inside the FL Digi CW controls. So right now I'm using a Hanning edge shape. You could also use black band. I'm using 53% weight, 3.1 dash to dot, and this is all variable. You just adjust that how you like to hear it yourself, or how you want it to sound over the air. And then this QSK goes out on the right channel, which is output 1, and this right here. And again, that goes to a second unit that keys the push to talk first. The reason we do that is the K3 operates CW much better if the push to talk jack is down first. So I'm able to time it by hitting the push to talk 8 milliseconds before the CW jack is keyed. And after the CW jack is finished, it hangs on just an extra 2 milliseconds so that there's no clipping of the RF wave, there's no shortening of DITs, and there's some DIT variancy on the K3, and that is cut in half. So instead of 6 to 7 milliseconds per element difference, there's only 3 or 4 milliseconds of element length difference as far as variance goes. So it's a much better way to key the K3 as far as in the experiments that I've run. And I think that's just about it. You have to have jack audio for this to work efficiently like this. I'm using 48K, 128 frames. We have some X runs, but not too bad since we're taxing it fairly well. The VU meter is what's coming to the input from me, from my remote computer. As you see, this needle is bouncing back and forth. The top meter is what's coming out of the K3, so I'm able to keep track of that. On this left side here with this IP camera, and you can, I think you can hit that remotely as well. You could also put a camera module on your Raspberry Pi, but that lets me see the RF wavescope, make sure there's no glitches or weird stuff happening to the K3 when I'm not in the same room or, you know, in a different, totally geographic location. The G-Rig is just fairly simple. It doesn't tax the CPU much, and it works good enough for this operation. There may be better ones out there, but this is a Linux native application. FL Rig is another one you can try, but I thought it had more chew on the CPU, so that's why I chose G-Rig to try it first. Anyway, thank you for watching, and I hope this is helpful. If you've got a Raspberry Pi, maybe you can try this too, and leave a link to your video demonstration. Thanks again.